is the logical addressing, right? So through internet, we will be able to communicate from one place to other place, right? So whenever the packets are or the data is being transmitted from one computer to other computer, we will be going through several LANs or WANs before we might reach the destination computer, right? So for this kind of communication, we need a global addressing scheme, right? So that particular global addressing scheme is known as logical addressing. So here we are using a term called IP address, right? So that is a logical addressing in network layer that will be present in TCP IP protocol suite. So here if you see in this slide, we have two different types of versions in internet protocol, right? One is IPv4 address and other is IPv6 version. So in IPv4 address we have 32-bit address. So that is very unique and it is universally defines the connection of that particular device from where we are going to transmit the data, right, through internet. So we know IPv4 address consists of 32 bits, right? So yesterday we have seen four octets, right? So in each octet, it is having 8 bits, that is 1 byte of data, right? So we know it is unique and universal. So if you see the address space for IPv4 version, it is 2 power n. So here the n is nothing but how many number of bits we are going to use in IPv4, right? We have already seen it is set as 32 bits, right? More than that we cannot use in IPv4 version. So 2 power 32 is more than 4 billion, right? So if you see here a representation or the notation is given. So if you see 128.11.3.31, it is a binary notation, right? Yes or no? So here if you see the decimal notation, we can see the binary and the decimal notations, right? So which is binary here and which is decimal here? Can anyone say? What is zeros and ones? Zeros and ones is binary, right? Yes or no? So here we are using 128, 11, 3 and 31 or all those are decimal, right? Yes or no? So to represent each digit, we have 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. So in this way we will represent it, right? Yes or no? So by calculating that, we will receive this as 128 and this binary as 11 and this zeros and ones as 3 and this as 31, right? So when we add all these zeros and ones, we will get 31 out of it, right? Yes or no? So this is how we will denote it, right? So number system we are using here. Yesterday I have shown this example to do the B part, right? Yes or no? So I hope you all know how to convert a binary into decimal and decimal into binary, right? So we have two different addressing techniques here. So one is classful addressing and other is classless addressing. So in classful addressing, we have the address space that is divided into 5 classes. One is class A, class B, class C, class D and class E, right? So if you take here how we find classes in binary and decimal notations. So if you take here the binary notations in class A, the first byte will be 0 and all other bytes will be host IDs, right? So this is network ID and these three are the host IDs present in class A, right? In class B, first two bytes are occupied, right? One is 1 0. So other two bytes are left empty, right? Yes or no? So in class C, first three are occupied and the last one is host ID. In class D, all. So this is a representation in binary. So for class A, if we see 0 in first byte, we will consider it as class 1. In class B, if we see 1 0, we'll consider it as class B. And in first byte, if we see 1 1 0, it will consider it as class C. So this is the binary notation, how we define which class comes under which binary values. So you know all the ranges how it is, right? For class A it is from 0 to 127, and for class B it is 128 to 191, and class C 192 to 223. So we have 255 till there the range can exceed, right? So under this we have classes, right? Yes or no? So if you see the example here, first they have given the binary values, right? So by seeing 0, we can identify first in first byte, first bit is 0. So by seeing first bit, we can identify it as a class A address, right? So by seeing 110, it is class C address, right? So this way we can identify by seeing the binary values whether it is class A address or class B or class C. So if you see 14, you can tell the range, right? 0 to 191 is the range. 127 is the range, right? For class A. So 14 is class A address and 252 is class E address, right? So by seeing example, you can find which class of addresses each addresses comes under, right? So if you see how many number of blocks and what is the block size in classful addressing, so you can see for class A, we will take 128 number of blocks. So the block size is different, right? Number of blocks is different and the size of block is different, right? So for each and every class, it varies, right? Yes or no? So in class for addresses, if we wanted to use a large part of the available addresses, so it will be wasted, right? If we are taking a more number of addresses, there may be a wastage of addresses while we are using a particular IP address, right? So if you take the default masks for class full addressing, so we know for class A, the first byte we have taken and the last three we will be considering it as host IDs, right? So the class addresses, if you see 25 255.0.0.0. So for class B it is first two bytes is 255.255.0.0. Yes or no? So for class C all three bytes will be like 255.255.255, and the last host ID will be 0, right? Yes or no? So if you see here, here they have given CIDR. So what is CIDR? So CIDR is nothing but classless interdomain routing. So here if you see, first byte contains 8 bits, right? So that is represented here. And the first 2 bytes is represented as 16 bits, right? And here the 3 bytes is represented as 24 bits, right? So all this will be a classless inter-domain routing. So we all know what is the default masks for class A, class B and class C. So in class full addressing, it is very absolute that how we address by using different types of classes. So if we want to replace it with classless addressing, how we will do? So if we wanted to use the out of range, like 2 power 32 is the range for classful addressing, right? So if we wanted to use for large companies or large industries, we wanted to exceed the range. So we will be going into classless addressing. So if you see here, uh, a group of organization is present which is having 16 addresses within it. So you can see the binary notation and the decimal notation they have given, right? So in IPv4 addressing, the addresses can be defined like, if for example here they have given x dot y dot z dot t slash n. So here the x dot y dot z dot t, we can take any numbers, like for example 10 dot 1 dot 0 dot 0. If you take this, slash n will be 16, right? So because you are using 2 bytes here, right? If I take that particular example, so here all this x y z and t, what it will defines, it defines the address which we are going to use, and the slash n will define the mask, how much default mask we are using, under which class we are using, right? So we already know that is 32 bits for IPv4 addressing, right? So if we take the first address in the block, we can found by setting the rightmost as zeros. So if you take this as an example, so in the question they have given a block of address is granted for small organization. So they have given the address and the default mask also they have given. So here we are going to find what is the first address in the block. So how we will find what is the first address is, first we will represent this in a binary form. So after representing this in a binary form, we already know IPv4 addressing consists of 32 bits. So take that 32 minus n. N is nothing but here it represents default mask, right? 32 minus 28 we have to do. So the rightmost bit will be 0 when we get it, right? So you can see here all the rightmost bits are zeros here. Yes or no? You can see here, right? So when it is converted into this, so what will be the address here? So 2 power 0, 2 power 1, 2 power 2, 2 power 4, 2 power 8. It will be coming in this way, right? So what is the value here? This is 32, right? Yes or no? So that is how we will get the first address. So now we are going to calculate the last address in the block. They have given in the question a small organization. We are going to find out the last address. So here we have like 32 bits for IPv4 version, and we are going to minus it with the default mask bits which they have given in the question. Now we are setting it to rightmost as ones. So for first address we have taken the leftmost and we have replaced it with zeros, right? So now for last address we are going to set the ones in the rightmost place. So now if you see same example, so what we have done is we have set all the rightmost as ones. So by calculating this, we will be getting it as 47, right? So this is the last address in that particular block, in that organization, last IP address, right? So that is how we calculate the first address and the last address. So here in the block, how we are going to identify how many number of addresses we can use. So the formula is 2 power 32 minus n. So minus n, you know what is n, right? N is nothing but the default mask which we are going to use, right? So in question they have given n as 28. So if we do this, the answer will be 16, right? Yes or no? 2 power 4 is 16, right? So another way how we are going to find out what is the first address and last address. So if we take a number of addresses that represent as 32 minus bit binary, right? So if they are given this as binary notations and they have given the default mask as 28. Now how we are going to find out is we are going to do unding operation to that particular mask, right? So we have seen In our lab experiment 3, if in IP addressing we have done unding and oring, right? Yes or no? So you all know how to do unding and oring, right? So the address which they have given, we have noted it, and the mask, we will get it by using which kind of class it is, right? See, here they have given the mask, how they represented the mask. So the mask we have to calculate, and we will be getting the first address. Similarly, for getting last address, we will be doing the ORing operation, right? So this we will do in class. So the next one is how we are going to configure the network for the given block. So if the given block is having a 16 small organization with 16 addresses, we know how binary notation and decimal notation, right? And we know how to find the first address and the last address, right? So if the first address is not assigned in a block and we are using some network address that will represent the organization, so how we have different types of hierarchies here. So if you see here, we will be having a two level hierarchy, right? So if you see all the fields which is present in the diagram, you can see the area, yes or no, area code, and you can see the exchange office, and you can see the subscriber here. So what all this will represent? So if you take a network addresses, it has subnet, right? So now you are seeing a figure, right? So that is a hierarchy in a telephone network. In some other place, for example, take North America. So we have different IP addresses as identifiers, right? So by which we can identify which location and which person is using that particular network, right? So here if we are seeing the hierarchy here, here the leftmost 3 bits. So this is defined as leftmost 3 bits as area code, and we have a exchange office here, right? So this exchange office will represent 3 digits here, and the last 4 digits will define here the connection or the local loop to the central office. So this is the structure of hierarchical telephone number which we are seeing here, right? So the next one, if you see in the slide, we have a frame in a character oriented protocol, right? So character oriented protocol, character by character, we will be checking, right? Yes or no? So it is two levels of hierarchy in IPv4 address. So here we will be having no subnetting here. So when we use this before diagram, there we have a subnetting hierarchy. So when we use this two level hierarchy, there is no subnetting here. So if we take IP address here, we will be having n number of leftmost bits in an address. So for example, if you have taken x dot y dot z dot t slash n, so we can know that what defines a network and what defines host, right? So if we take an organization network, so it will be defined the network, and 32 minus n rightmost bits will be a particular host, right? So here we are using two common terms. That is, one is prefix and other is suffix. So prefix will be denoted for network IDs, and suffix will be denoted for the host IDs here. So if you see here, we are using generally the prefix and suffix notation here. So in leftmost n bits, if you take for example x dot y dot z dot, slash n if we take. So here if the network, for example 10.0.0.0, so 10.0 is the network in this IP address, right, which we are taking as an example. So here the 10.1 will be the prefix and the last two 0.0 will be left out, right? So if we take 0.0.1.10, so that 1.10 will be the host ID here, right? That will be called as suffix here in two level hierarchy. So the configuration and the addresses in a subnetted network, right? So if you see in this diagram, you can see how we are configuring and subnetting, right? So in the figure, if you see, we have three subnets, 1, 2, and 3, right? So here the notation we are going to use is x dot y dot z dot t slash n. So here they have given an organization networks as subnet 1, subnet 2, and subnet 3. So in router, through router, we can communicate from one subnet to other subnet. So if in an organization we have different parts of people who are working under different, for example, if you take our college, we have different departments, right? So one department need to communicate with other department. So how we will be communicating by using configuration and addressing is through our PCs and laptops, right? So we will be connecting to the internet through a router, right? So that we can communicate from one department to other department, yes or no? So if you take here the three level hierarchy structure, we can see here. So here the network prefix and subnet prefix and host addresses are there, right? So how we will communicate through subnets? We will be using the internet as a medium and we will be communicating through different subnets, right? So the next one is this three level hierarchy, right? So in three level hierarchy, we will be having so many levels of hierarchy. So if we consider classless addressing, there is no restriction how many hierarchical levels we are considering in an organization. So that we can give a block of addresses into sub blocks. So if we consider one sub block, that can be divided into different smaller blocks, right? So for example, if we take this ISP, what is ISP? Internet Service Protocol, right? So we have national service providers, right? Internet service providers, we have ISP, right? So that will be divided into different large blocks, and the large blocks can also be divided into smaller blocks, right? So whenever we assign each of them to regional internet service providers, so that will divide the blocks and receive the national internet service provider into smaller blocks, right? So that it can assign to each local internet service providers. So the local internet service providers will divide that blocks into regional internet service providers. So that will be again divided into smaller blocks so that it can send the data from one organization to different organizations, right? So this is how we can divide different blocks. So all these blocks can be considered as subnets here. So how we will give address allocation here? It is one of the problem how we allocate, right? So unique, it is a very unique and it is very universal, right? While we are addressing. So while we are allocating the address by using global authority, that is called Internet Corporation for assigned names and addresses. So that is known as ICANN. So it does not normally allocate addresses to individual organizations. How it does is it will assign a large block of addresses in internet service providers. So that internet service providers will divide it into assigned blocks, and that will be given to smaller sub blocks which is divided, and it will grant it to the customers, so that the receivers which receives large block will be distributed to its internet users. So this is called address aggregation. So how we aggregate the address from many blocks to one or granted internet service provider. So if you see this here in an example, how address allocation and distribution is done by internet service providers. So they have taken as small groups. So the large group is divided into small subgroups. So the subgroups again it is divided by using internet service provider, and it will give to that particular customer, right? Yes or no? So how we will give addresses for private networks? So you can see the ranges here they have given. So here it is class A and class B and class C, right? So in class A you see the range, that is 10.0.0.0 to 10.255.255.255. So this is the range that they are using for class A, class B and class C, right? So what is NAT and how we are going to implement it, we are going to see, right? So what is NAT here? Can anyone say what is NAT? So network address translation, right? NAT is nothing but network address translation. So if we take an example, we have different home users and small businesses that wanted to use the internet wherever they are increasing their organizations, right? So if a user wanted to connect it to the internet, what they have to do, they have to use a dial up line, which means they need to connect it for a specific period of time, right? Then only they can use the internet at that particular amount of time, right? So if you take here the internet service providers with a block of addresses that is assigned already dynamically to the users, so the address will be given, right? So in a situation like if home users and businesses are connected to some other line or cable modems, so they are not happy with one address, they wanted to create other small networks with different hosts, and they need IP addresses for each host which they are going to create, right? So if the shortage of addresses is present here, it will be a problem here. So for that particular problem, the solution is network address translation. So what network address translation will do, it will be enabling user to have large set of addresses that may be internally and one address, or small set of addresses externally. So internally they can create any large set of addresses, but externally they need to create a small set of addresses, so that the traffic inside the large set and outside can be able to manage, right? Yes or no? So for using this NAT, we are having the private networks. We have seen here the addresses, right? So for using NAT, we are using this private networks to increase the range, right? So here if you see, we are using a internet and this network address translator router, and we are using different PCs and devices, right, to communicate. Yes or no? So how we translate this address by using this structure, how we implement by using end users, router and internet. So if you see here, we have a different source and destination here. So if you see here, the source and the destination part will vary, but the source will be going through internet, but the destination will be coming from through internet, right? So here what we are going to do is the outgoing packets that we are going through this NAT router, that will replace the source address in the packet by using global NAT address. So whenever the incoming packets pass through the router, it will replace the destination address in the packet. So if you see in this example, you can see whenever it is going, it will be changing in the destination address, right? So here we will be using a translation table, so that we will be having a reader that will notice all the translations while we are sharing the data from sender to receiver, right? So the source address for outgoing packets will be straightforward in this reader. So how we will note the destination address coming from the internet will be same or different. So there may be tens or hundreds or different private IP addresses that may belong to same specific host, right? So when we are using, so by using NAT, we will be solving the problem by using NAT, by using the translation table. Here we are using only one IP address here. So the translation table will have two columns. So how we will do? One is private address and other is external address. So here the external address will be the destination address that is coming through internet, right? So when the router translate the source address of the outgoing packet, it also should note the destination address where the packet is going, right? So it has to take a table where source and destination packets, from where it is going and from where it is coming. All the responses should be handled by using translation table, right? So here we are using a router that will have a source address of the packet, so that here we will be finding the private address of this particular packet address. So if you see here in an example, we have different source and destination. But when it is coming through one source to other source, so the destination may vary, right? So here if you see, the destination is 225.8.2.10, and here the destination is 25.8.2.10. So when you consider the source, so this source is different and this IP address is different, right? So whenever we are using both this IP addresses, we need to handle what are the changes and how it is going through the internet, and how the destination address is coming from the internet. We have to note it in a translation table. So one is for private and one is for external. So we are using two different IP addresses, right? So one column is used for private and other column is used for external, right? So we have a different port numbers that is present, and which kind of protocol we are using, that also we can be noted, right, in translation table. So if you see here an example, we have different IP addresses. We are using the internet service provider through which we are sending the address to internet, right? So here we are using both internet service provider and NAT, right? national addressing translation, right? So we have a different protocols, right, to use each and every services and to share from one protocol to other protocol. We have different IP addresses and different port numbers, and we have different protocols, right? So if you see in this diagram, we are using internet service provider. So what it will do, it will give the customer this NAT technology to conserve the addresses, right? For suppose if you take an example of, you have granted some 1,000 addresses to internet service provider, but you have only 1 lakh customers here. So each customer need to assign a private network address, and this internet service provider should translate each of 1 lakh source address into outgoing packets, right? So that may be one of the 1,000 global addresses. So what it will do, it will translate the global destination address, and it will give to the incoming packets that will correspond to the private address. So that it is showing in this diagram. So the next one is IPv6 version addresses. So we have short-term solutions in IPv4 addresses, right? If we wanted to increase the range for all this. So if we want to have a long-term problem for the internet, and we have solutions in IP protocol itself, right? So to solve all this, we have IPv6 version here, right? So IPv6 address is having 128 bits long. So IPv4 is 32 bits and IPv6 is 128 bits long, right? So here if you see the binary and hexadecimal colon notation here, you can see 128 bits, that is 16 bytes, right? So here we have 32 hexa digits, which is denoted from binary to hexadecimal colon notation, right? Yes or no? So how we denote here, how we denote the structure of hexadecimal colon notation? So to make address more reliable, we will be using IPv6 version here. So here we are using 128 bits here, right? We are using 8 sections in this example, right? So each 2 bytes in length and 2 bytes in hexadecimal notation. We are using 4 hexadecimal digits, right? So if you see in this example, we are using 4 hexadecimal digits in each, right? So here the address is consisting of 32 hexadecimal digits. So for every 4 digits separated by colon, we have 32 hexadecimal digits, right? Yes or no? So if you see how we are going to abbreviate IPv6 address, you can see the original data and how we are converting it, and how we are converting it into small, right? So we have IP address in hexadecimal format, right? It is very long, and we have many number of digits are there with zeros, right? Yes or no? So in this case, what we are going to do is we are going to abbreviate the address. So here, the leading zeros of a section, we have 4 digits, right? Yes or no? We have 4 the third portion, fourth portion, fifth portion, and seventh portion, we have 4 zeros, which is represented, right? So we are going to omit it, and we are going to drop it as small, simple small zero, right? So the next step, you can see we have given it as zeros. So using this form of abbreviation, what we are going to write is, so instead of using 3 different zeros, we have included 1 colon, right? Yes or no? So this is how we can do, right? So the next one is address space. So how we are going to see address space and what are the prefixes and suffixes that we are going to use in IPv6 addressing. So we all know in address space it is have 128 bits, right? So how we denote larger addresses? By using 2 power 128 addresses are available in IPv6 version, right? So we can divide the addresses into different categories. So it can have a few leftmost bits. So that leftmost bits type is called prefix. So in each address it defines its category. So if the type prefix is variable in length, so it is designed with no code that should be identified. So if the first part of other code, if we take it, so there is no ambiguity in this, right? So when an address is taken, for example, the type of address is prefix that can be easily determined by using a table which is given right here. So each type of address we have three different columns here, right? So one is fraction, other is type, and other is type prefix, right? So by this three columns, what it is showing is how much fraction of each type of address is relative to the address space, whole address space which is given, right? So if you take here, we have different type prefixes here. So what is the type of prefix is also given here. One is reserved, unassigned, and reserved and provider based unicast address. So this is the fraction that it takes to that specific addresses they have given, right? So all these are a type prefix type and the fraction which we are going to use, right? So here we are going to see the prefixes for provider based unicast address. So we all know we have a unicast, multicast and different addresses, right? Yes or no? So what unicast address will define a single computer. So if a packet is being sent in unicast address, so that must be delivered to that specific computer, right? So here we are going to use IPv6 version that is going to define two types of unicast addresses. One is geographical based and provider based. So now we are going to discuss the second type, right? So the first type is we will be discussing later, that is geographical based. Now we are going to discuss the provider based address. So it is generally used by a normal host that is known as unicast address here. So if you take here the example, we have different fields for provider based address, right? So the first one is type identifier here. So what it will do is it will say how many bits we are going to take to that particular field and what based address we are taking here, right? So type identifier is having 3-bit field that is defining the address as provider based address. And you can see here internic, RIPNIC and APNIC. So that is taken as registry identifier, right? So this registry identifier is holding 5-bit field. So what it is doing is it is indicating the agency, which agency has registered this address. So currently we have three registry centers that is defined here, right? So with some specific code also they have defined, right? INTERNIC 11000. This is a specific code for that particular center which is provided in that particular area, right? So these are given here. And the next one is provider identifier. Next field is, so this provider identifier is a variable length field. What it will do, it will provide the internet access. So it will provide the internet service provider. So it has a 16-bit length for this particular field. So the next one is subscriber identifier, right? So when an organization want a subscribers to the internet through a provider, what it will do, it will assign a subscriber identification. So that will be having a bit length of 24. So the next one is subnet identifier. So each subnet can have many different subnetworks, right? So we have a unique identifier here. So that will define which specific subnetwork will come under that particular subscriber. So it is having a 32-bit length. So the next one is node identifier here. So this is the last field. What it is going to define is, it is going to identify which node is connected to a subnet. So it is having a 48 length bit. So which is having a link address. Link is nothing but a physical address, right? It is used by Ethernet. So here we will be having a physical address, right? So this is about unicast, and next one is multicast, right? So here we have a different fields, right? So if you see the multicast, we are used for a different group of hosts instead of only one. Unicast is nothing but we are using only for small or single, right? Here we are going to use for group of hosts. Here we have a multicast addresses that will deliver to each member of that particular group, right? So if you see the second field here, that is the flag, right? So that will define how many group addresses, whether it is permanent or temporary. So if it is a permanent group addresses, so it should define the internet authorities that they are going to access all the times. So if it is transient group addresses, so it will be saying it will be used only temporarily, not permanent. So here the systems will engage in teleconferences. So for example, if you take a temporary, that is transient group, we have a group addresses. So we have many different scopes here, right? Yes or no? So the next one is, IP IPv6 we are discussing, right? The next one is any cache address. So here we can have a combination of multi addresses, and we have the nearest one, and we have different one, right? So the next one is reserved addresses, right? So how we are going to reserve the addresses in IPv6? Yes or no? So how we are reserving according to the address space, by seeing which category and which type of prefix it comes. By seeing that, we will give the reserved addresses, right? So the next one is unspecified address. So if you see here in reserved addresses, the first one is unspecified address, right? So it is used when a host doesn't want or it doesn't know its own address, then it will send an inquiry to find its address. So for that we will be using unspecified address. And the next one is loopback address. So in loopback address, it is used by a host to test by itself without going into another network. So the next one is compatible address. So what compatible address is going to do is, it is going to use for the transition. So how we are converting the IPv4 version to IPv6 version. So whenever a computer is using IPv6 version, it wanted to send a message to other computer using IPv4 version or IPv6 version, it need to pass the information through that particular network, right? For that we are using compatible address here. And the next one is mapped address. So in mapped address, during transition, we are going to use that a computer may migrate from IPv6 and it wanted to send a packet to a computer still using IPv4 version here, right? And the next one is local address, right? So what we will do in local addressing? So if an organization is present in a local area where they are using IPv6 protocol without connecting an internet, so here we need to provide addressing for private networks, right? So nobody from outside the organization can send a message to the nodes or the end users using addresses, right? So here we have two types of addresses. One is link local and other is site local, right? So link local address is nothing but it is isolated to that particular subnet. And site local address is like isolated to that particular site which the organization is using, right? Yes or no? So this is about IPv4 and IPv6.